All right, for those of you who are ahead of the pacer, or those of you who were absent for the whole class lecture, a video copy of the lecture is here for your convenience. So in this module, we'll be talking about elements, compounds, and mixtures, which are really just subsets of matter. Matter, and you should write this down, is anything that takes up space and has mass. So anything with volume and mass qualifies as matter, which is almost everything in chemistry and almost everything in the world. Matter is made of atoms. So these atoms together, they take up space, they have mass, and it makes up everything that you can see and feel around you. Even air has mass, so even air is matter. But we divide matter into two categories. We have pure substances and we have mixtures. A pure substance is a sample of matter that has definite chemical and physical properties. So we know something about it. We know what it acts like, what it looks like, how it behaves. And some examples of pure substances are elements and compounds. Atoms are what make up elements. So if you divide gold into 1,000,000 pieces, it'll just be atoms of gold. And molecules make up compounds. Elements are pure substances that cannot be separated into a simpler substance by physical or chemical means. That means we can never separate it. So if I took a block of aluminum foil and I cut it in half, and then I cut that in half, and that in half, and that in half, and that in half, and so on, I would never get anything that wasn't an atom of aluminum. So it just cannot be separated. And then you'll eventually get it to one atom, and it will still just be that pure substance, that pure aluminum. Compounds, on the other hand, are pure substances, but they're composed of two or more different elements that are joined by chemical bonds. And you identify these by a chemical formula, and you can separate them by chemical means. So you'd have to do an experiment, not physical means. I couldn't strain them, I couldn't filter them. You know a specific compound, you drink it every day, and that's water. And the chemical formula is H2O. That means that it is 2 hydrogens and 1 oxygen. The thing about compounds, though, is that's always the same. If I said that water was H2O2, I would be wrong, because that's a new compound. That's hydrogen peroxide. So elements and compounds are the two types of pure substances that you'll be responsible for knowing. Mixtures, on the other hand, are a combination of 2 or more pure substances that are not chemically combined. They're held together by physical forces, not chemical. So if I'm making chicken noodle soup and I put all of the ingredients into the pot, that's held together by a physical bond. I could separate those out, and no chemical change takes place. So each ingredient that I put in my chicken noodle soup still acts, tastes, smells, feels like the ingredient it was before I put it in the soup. So each item retains its properties in the mixture, and you can separate it physically. Salt water. Your salt is still salt, your water is still water, and then if I evaporate the water, which is physical, I'll separate out the salt. What I want you to do, if you are not joining us in class, is copy down this table so that you know the difference between mixtures and compounds in your notes. So if you are watching this video at home, go ahead and pause this video until you have this written down. I will be checking your notebooks for this present. The next thing we are going to do is do a little identification game. And you need to tell me if each photo represents an element, a compound, or a mixture. So review those definitions for a second, and then we'll get started. Alright, so you're going to look at these pictures and you will tell me if it is an element, a compound, or a mixture. Our first is rocks. So the questions you should be asking yourself: can you separate it? Is it made of multiple things? Does it show up on the periodic table? and how are they combined? So what do we think for rocks? Element, compound, or mixture? Rocks are a mixture. Next is copper. Element, compound, or mixture? Copper shows up on the periodic table. It is an element. If I cut into that piece of copper wire, I would simply get more pieces of copper. Jelly beans, element, compound, or mixture? Jelly beans are a mixture. You just put those together in a bag. You can separate them by eating them. Table sugar. Table sugar is a compound. It is a combination of carbon, hydrogen, and oxygen. That is its chemical formula on the slide. C12H22O11. If you tried to filter out the carbons, the hydrogens, and the oxygens by physical means, you could not. You have to do a chemical experiment to separate sugar. Diamonds, element, compound, or mixture? Diamonds are actually elements. While you do not see diamond on the periodic table, they are simply made of carbon. Carbon that has been heated and pressured for millions of years becomes diamond in the ground. Tea, element, compound, or mixture? Tea is a mixture. Think about how you make it. You put the tea bag into the water, and the herbs steep through. Salt, element, compound, or mixture? Salt is a compound, otherwise known as NaCl. Both of those are on the periodic table. It is a combination of those two elements. Neon gas, so the gas used to make these signs. Neon is an element. It is Ne on the periodic table. It is a noble gas, which you will learn about in quarter 2. Salad. Salad is a mixture. Pure water. That should give you a hint, and we talked about it. Water is a compound, H2O. Aluminum, we also discussed. Aluminum is an element. Lemonade, think about how you make it. What are the ingredients? Lemonade is a mixture. Silver. Silver is an element, Ag. It is the second level of all of your assignments on Canvas as well. Sand. This one is a little bit more difficult, but sand is actually a mixture. So if you look here, you should also be copying down this into your notes. I will be checking for this as well. So matter is anything that has mass or volume, so takes up space and has a weight to it. If it variable composition, this means does it change? If it changes, then yes, it's a mixture. If it cannot, it is a pure substance. Can you separate it? No, that's an element. It's on the periodic table. That's how you would identify that. Yes, then it is a compound, like water. And then your two types of mixtures are heterogeneous and homogeneous. Do they look the same throughout or no? So, chicken noodle soup, I can tell all of the different parts of it. It does not look the same from top to bottom. That is a heterogeneous mixture. Milk looks the same throughout. So I can't tell one part of the milk from the other part of the milk, and that is a homogeneous mixture. If you know the words homo and hetero, they mean same and different. So homogeneous mixtures look the same all the way through. Heterogeneous mixtures look different throughout. Please let me know if you have any questions.